So this question, I've obviously taken a lot of the words out, but I mentioned this last day. There's some key words in there. Can anybody from last class tell me about that? Yeah, it's the rate proportional that you have to clue into here. So I'm going to write it down for you just to remember that when you hear this, something grows or decays at a rate proportional, that's trying to hint to you that this is talking about growth and decay. So it's going to likely end up using one of the forms of growth and decay that you know. Some of it you learned in Math 12, but this one, of course, relies on calculus. So let's talk about why this question makes sense and how it could be answered quite easily. How much temperature is this corpse going to lose? It's got to decrease, right? It says it's 32 degrees Celsius and the morgue is 10 degrees. So think about it. What's decaying here? How much stuff is decaying? 22 degrees will end up disappearing, right? So that's what's getting eaten away. But it's not, the way the problem is spelled out to us is this telling us that that's the energy that we're dealing with, that we're going to erode away. But that's the instant right now is 22 degrees the second we put it in the morgue, right? So, maybe the mortician has a cup of coffee and they come back and now the corpse is 30 degrees, right? How much is going to decay now if the body's 30 degrees when he comes back? 20 degrees, okay? Then he gets a phone call and his girlfriend is just got some major problems to deal with. And it takes him 10 minutes before he gets off the phone. And now the corpse is like 18 degrees. How much is left to decay? How are you doing this magical calculus in your head? Because you're smart, yes. But what are you doing in your head? Just tell me how you're getting the number. You're just subtracting, right? So basically you're taking the temperature and you're taking away the 10 degrees. That's how much energy is left in the corpse. This is what is decaying at a rate proportional. We don't know what that rate is, but when we don't know what the rate is, we use a letter, like K. Okay. So this is the start of what we're saying. The change in temperature with respect to time is proportional to, right? That's how we're trying to set it up to take the English and turn it into a calculus equation. So here, once we do that, okay, well, we end up with A. Why would there be a negative in front of their answer? Yeah, it's decaying, right? So because it's decreasing, we need to have a negative rate of change. This number here is always a positive, and this is going to end up making the whole thing overall a negative. Because this is decreasing. Okay. So we get A for an answer there. Do people want to, does that make some? It's definitely tough the first time you see that kind of thing, but that's what we're getting at. I'll just, here, let me, I won't include, should I include, I'm gonna actually show you where the formula would go in case that was the second part of this. Do people want it in the video or not? In the video, okay. So here's what I'm saying is this is the differential equation that I just set up, and you may then be asked to find a model for this, okay? So how could we find a model for it? Well, we're going to use some integration and solve this problem. We'd have dt over t minus 10 equals negative k dt. Separate my variables, and then I'd have to solve my differential equation. Okay. To do that, this is going to be the natural log of t minus 10. And this will be negative kt, right? K is a constant. It's the proportional, the rate at which it decreases, right? Like if it was an interest rate, it would be like 5%. It's always increasing or decreasing at that same constant rate. So this would be the setup I have. Then I would solve this for the temperature. E to the negative kt plus the constant is t minus 10. And now when I substitute, if I read the question, what point could I use to solve some of these things? Can anybody think of something? Okay, I'll give you a hint. Yeah, 32 degrees at time 0. So when I plug these things in, then I'm going to get 32 e to the 0 equals t minus 10. And, okay, so that's going to be a 1. Oops, sorry, here, let me, my, thank you, yeah. I guess my brain is still a little bit on spring break here. It's good to know that you guys aren't. So there'll be a 0 here, and that should be 32. Thank you. Okay, so that becomes a 1, and I have c equals 22. So what this final formula then would work out to be, this is where we were, it would be 22 e to the negative kt plus 10 equals t. So there's my equation for the time. Now you can tell me a time. I can tell you the temperature of that corpse. Don't go to the morgue and do this for fun. It'll gross you out. But if you look at these problems, this should make a lot more sense to you as a calculus student than it did as a Math 12 student. Why is there a 22 here? In Math 12, we would have said, well, that's the initial amount, Mr. Joyce, but why is it there? Magic, yeah. No, it represents the amount that's going to decrease, right? 22 degrees is going to disappear. So that's what's being eroded, and it's being eroded by this guy right here, right? Why is there a plus 10 there? It can't go below plus 10. This is the asymptote if you were to graph this, right? So if we run across this question and you had to come up with a formula really quickly, the more you understood it, some of you will get to the point where you can write the equation without doing the differential calculus, because you'd say 22 degrees is the amount to decay, and the temperature in the room is 10. So this would be, in one shot, you could write it out if you understood the problem that well. So it's not necessary, but again, if it saves you time on the exam, it's obviously a good thing. Okay, so I'll put this one up here.